Hello again, it's Dave Giles here for the next lesson of Cambridge International Education IGCSE Physics, Unit P1, which is motion, force, and energy in a day, and we're looking at density of liquids. And I want you to determine the density of a liquid experimentally, or at least describe how you would, and determine if an object will float. So this is going to be a fairly short lesson because if I was teaching this in a classroom, there'll be a lot of practical involved. So it's more going to be talking you through briefly how you would do the practical instead. So if you want to get the density of a liquid, obviously you can't just measure width, length, width times height. So what you would normally do is you would take there's one way of doing it. You would take a measuring cylinder, empty, then fill it with the liquid and weigh the difference. So you can see here the mass has gone up from 200 grams to 250, so it's gone up 50 grams. The volume is 25, no units on, oh sorry, centimeters cubed. So density of mass, 50, over volume, 25. So the density of this is 5 grams per centimeter cube. Another way of doing it, and the way I would normally do it instead, is I would measure it in a measuring cylinder, then use a beaker, put it on the scale, top band balance, tare, which means reset to 0, and just pour the liquid in. But there are different ways you could do it. A little note, it says centimeter cubed on here. Most measuring cylinders you'll find will actually have milliliters on. Now, 1 milliliter is the same as 1 centimeter cubed. And there's one substance where you probably should know the density of it. Something you should probably remember is the density of water, which is 1 gram per centimeter cubed. That is for pure water. It would be a little bit different if we're talking about tap water because there's some impurities in there. So why do you think water and oil look like this when you try to mix them? Well, the reason is that oil is obviously floating on the top. This is the oil here, and it's because oil is less dense than water. So the density of cooking oil is around 0.92 grams per centimeter cubed. So it's a little bit less dense than water. So because it's less dense, it floats. Okay, so question. A solid has a density of 0.965 grams per centimeter cubed. Will it float in water and or cooking oil? Give you a few seconds to think about that and answer it. Okay, so the density is less than water. So it will float in water. However, the density is higher than oil, so it will not float in oil. It will sink to the bottom in oil. Okay, so it is a fairly short lesson, like I said earlier. So now it's a series of questions. So we'll have a look at some paper 2 questions. Diagram shows 4 pieces of lab apparatus. Which piece of apparatus are used to find the density of a liquid? It's a balance and a measuring cylinder. So a measuring cylinder contains 30 centimeters cubed of liquid. Some more of the liquid is added until a liquid level reaches the 50 centimeter cubed mark. The reading on the balance increases by 30 grams. What is the density of the liquid? So the volume is increased by 20 centimeters cubed. So density is mass, 30 grams, divided by the increase in volume of 20. So that gives you 1.5 grams per centimeter cubed. Now, this question here is actually about the density of a gas. However, the way you do it is exactly the same. So, seal contain a volume 2,000 centimeter cube contains air at high pressure. The container is placed on a top band balance. The balance reads 200 grams. All the air is removed by a vacuum pump and the balance reading changes to 196 grams. What is the density of the pressurized air? So the air that was removed is 200 minus 196, so it's 4 grams. So the density is 4 divided by the volume of 2,000. So you get 2 by 10 to the minus 3. grams per centimeter cubed. So the answer is A. The tables give data about 4 liquids, W, X, and Y. None of the liquids mixes with any of the other liquids. All liquids are put in the same container and settled to form 4 separate layers. Which statement is correct? And basically, it's about where they will all land. So what you need to do is work out the density of each liquid. So, and I haven't got my pen with me, so I'm just going to have to write using the pen function here, using my mouse. So I'm going to work out the density of each liquid. Seconds. So the first one is mass over volume. So it's 10 divided by 10, which is 1 gram per centimeter cubed. Bear with me while I look for the pen on here. Okay, the next one is 20 divided by 15, which gives me 1.3. Now, I'm not writing the units purely because I'm using a mouse to write this down, and it's not easy to write with a mouse. Next one is 30 divided by 50, which is 0.6. And then 40 divided by 50, which is 0.8. Okay, so let's go through the statements. W forms the layer below X. W forms the layer below X. No, W will be above X because W is less dense. X forms the top layer. Well, actually, X will form the bottom layer because it is the most dense liquid. Y forms the bottom layer. Quick look, Y forms the bottom layer. And the last, no, Y will form the top layer because it is the least dense. Z forms the layer below Y. So you've got Z to be below Y. That is correct because after, pardon me, after Z, Y is the next least dense. Okay. So it's D. Okay, the next lesson will be on scalars and vectors, and I will be uploading that probably later today, and I'll post a link down in the description. Thank you.